Greetings, YouTube. Beautiful mind Pfeiffer here to answer a few questions from college algebra. Okay, so this first question comes from section 1.1 of our text. It's question 27 from the back of that book. Let's go like this, make it a little bit bigger. Okay, and here it is. So we're asked to solve this equation. I'm going to start by writing a copy of the original. So if we have 0.5x plus 4/3 x equals x plus 10. If we're going to solve for x, so first thing I like to do is isolate the variable. So we want to get any term that has an x on one side and everything else on the other. So let's see, we have this 0.5x, we have this 4/3 x. We're going to subtract x on both sides. So minus x and minus x. So we're going to say minus x equals 10. So what we want to do, I'm a fan of clearing fractions and decimals. So since this has both, let's just do what's necessary for both. So in order to clear decimals, I multiply the left and the right by the appropriate power of 10. And that's my dog. Hey, come here. She wants to help. She's offering protection, but she don't realize what she's doing. But that's okay. Thank you. Stop. Thank you. Okay, so if we wanted to clear the decimal, we're going to multiply the left and the right by 10. Since there's one decimal place, we're going to multiply by 10 to the power of 1, okay, on both sides, and this will preserve equality. So we're going to say that times 10, this times 10, and this times 10. Okay, so if we do this, what happens, so we'll get 5x, that's going to be 40 over 3x minus 10x. Now this might be complicating it, but for right now, I just want to bring up this thing about clearing decimals and clearing fractions. Okay, so now we still have a fraction, so let's multiply the left and the right by the least common denominator of the fractions. At this point, the LCD is 3, so we're going to say the left and right by 3. So we're going to say this times 3, and again distribute our 3. So after this procedure, not only have we cleared the decimals, but we also cleared the fractions. So then 3 times 5 is 15x. 3 times this middle term, I'm feeling like purple right now. So then 3 times this middle term here, the 3's cancel, because we're going to have a 3 on top and a 3 on bottom. They're going to cancel. And so we're left with a 40x there. And then minus 300x equals 300. Okay. At this point, we have one equation, one unknown we can solve. I mean, we've always had that the whole while, but okay. So now we've cleared all our fractions. We've cleared our decimals. So then we just want to combine like terms. 40 and 15 is 55. What is that? 245. Negative 245. X equals 300. So divide both sides by that negative 245. X equals 300 divided by a negative 245. Let me see. I think I'll just use my calculator to finish this part. Hopefully, let's see what we got going here. Okay. Yes, that's what I want. Oh, okay. Okay. So if we said 300 divided by 245, I'm going to do math as a fraction. 60 over 49. Let's see, how do we do? So then our claim is that x equals a negative 60 over 49. Okay, now if that's correct, if we plug this value into the original, it should be true, right? So how do I want to do it? Yeah, I'm just going to plug it into the left and the right and show that they're equal. Okay. So let me get a copy of the left. That's 0.5 times x plus 4. Let's do it like this. Parentheses 4 divided by 3, close parentheses, times x. That's the left-hand side. I'll go ahead and put the right-hand side down, or that's fine. X plus 10, okay? So we have the left and the right. So then what we're going to do, we're going to go to variables, y1. So when x is, I think we got a negative 60 over 49, negative 60 over 49, we'll get an answer, right? So then let's see, when we plug in that fraction on the other side, do we get the same answer? What if we hit math as a fraction? Okay, we get something like that. Let's do our negative 60 over 49 plus 10, math as a fraction. So we made a mistake somewhere. Wait, let's do, I think it's still good. We'll still get the same thing. We're going to go to variables, and I want to call the second function negative 60 over 49. So let me go back and check my work to see if we can find out where we made this mistake. Okay, I thought that looked a little funny. Let's look at it again. We got 0.5x, 4/3. Okay, so we have a copy of the original. If we multiply by 10, that becomes 40, right? That becomes 10x and 100, okay. If we multiply by 3 on both sides, that's 15. That cancels. Oh, I see where I made my mistake. When I multiplied by 3, I put 300 and it should have been 30. So this right here is where I made a mistake, right there. So that should have been 30x. Okay, so let's make that adjustment. So that means everything after that point, see my dog trying to help got me distracted. It's okay. So everything after that was wrong. So what I'm going to do is clear everything after that and start from there, right? So that's important. It's important to be able to do that, though. Like, you see how we got to the end, we got an answer, and then we checked to make sure if it made sense in the context of the original, and it didn't. So we knew somewhere we made a mistake. So then that was my flag to say, wait, let me go back and look at this again. So let's make that adjustment. So we're saying that this was supposed to be a negative 30x, and let's bring everything else down. I'm going to just go ahead and get a copy of these items. Copy, paste. I think everything else stayed the same, right? We just made that one adjustment. Okay, so let's make that adjustment and go forward. Okay, so now here if we combine like terms, let's see, 40 minus 30 is 10, plus 15 is 25x. Equals 300. Divide both sides by 25. X equals, what is that? 4 times 3 is 12. X equals 12. Okay, that feels a lot better. So now let's check this in our calculator again. Now if we got an answer of 12, we're going to call that first the left-hand side. Come on. Are you not working now? Okay. So we got what? 12, right? So let's plug in 12 and we get 22. Now let's plug in 12 on the other side. Let's just go like this. This one, let's plug in 12 here. And we get the same result. That feels much better. Okay? So now I feel comfortable saying that 12 is the correct answer. And the reason, I'm leaving this unedited, I'm just doing this on the fly because that's how it goes on an exam. You get an answer, you got to ask yourself, does this make sense in the context of the original? So notice I got an answer, I checked it in the original, it didn't check out. So then I knew somewhere there was a mistake, so I went line by line, I took my time, and we found the mistake, okay? So, and I'm going to leave that there for you, okay? That was the first one. The second question comes from the same section. It's question 31 from the back of that section. The instructions say, determine whether each equation is an identity, a conditional equation, or a contradiction. Give the solution set. So there was a request for number 31. So first I'm going to start by getting a copy of the original. So then we have 4 times 2x plus 7 equals 2x plus 22 plus 3 times 2x plus 2. All right, so there's a lot going on in this one. Give me just a moment. Okay. You gonna come help me this time, or you gonna keep being a distraction? That hurts. Get down. Come on. All right. So we got a little bit of assistance from the light bright malachite. Okay. Okay. So let's start by distributing over these parentheses, the multiplication over addition. So we can distribute here and here. We also can distribute here and here. All right. So if we do this, we have 8x. 7 times 4 is what? 28. Let me do this in 2 steps. 2x, 22. If we distribute to 3, 3 times 2 is 6x. 3 times 2 is 6. Let's set this as 0. I'm going to move everything to the left, right? So I'm just going to bring down the 8x, bring down the 28, subtract the 2x, we get negative 2x. Subtract the 21, we get subtract the 22, we get negative 22. Negative 6x minus 6 equals 0. Okay? Next, we want to combine like terms. Okay, so we have a term with an x term here. Here's another x term. Here's another one. And I am feeling blue. We can do blue as well. So the blues are considered like terms. So we're going to go ahead and combine those. 8 minus 2 is 6. 6 minus 6 is 0. So those essentially, they all cancel. So that cancels, all of those cancel each other. All right? So then we're left with, let me see, 28 minus 22, I think that's also 6. 6 minus 6 is so when we combine like terms there as well, those cancel as well. So ultimately, we finish with 0 equals 0. Notice that this is a true statement. This is true, right? So because all of our variables cancel and we finish with a true statement, the solution set would be all reals. Any real number x is going to work in the original, and this is what we call an identity. So this would be an identity. So this is an identity. Let's go back and make sure we answer the question. Determine whether this is so it's an identity, and the solution set is going to be all reals, negative infinity to infinity. So we're saying that any real number x is going to work in the context of the original. Okay. Okay, so we're going to do this as an extra credit opportunity right now. I will offer this extra credit to the first... We'll do the first... What time is it? Okay, we'll do the first 3. So the first 3 students, let's do a secret word of what do I see around the room? We'll just say red rose. So the first 3 students that email me red rose. So the time, this is what, August 21st at 10:16. First 3 students that email me red rose, I'll give you extra credit just for watching the video, and that's just going to be my Easter egg. So that's an Easter egg. I had one student actually claim an Easter egg that I mentioned from like almost a year ago. I said, yeah, I'll honor it. So because she watched my video, she heard it. So yeah, you can. I decided to go ahead and give it to her. But yeah, so we'll let this Easter egg be red rose. So the first 3 students that email me that with the secret code, I'm willing or I'm open to giving a little bit of extra credit for that, just for watching the video and being attentive. Okay. Oh, another extra credit opportunity. So with any of these videos, if you find an error like at the end of the video, if I leave an error like a wrong answer or anything like that, I offer extra credit for correcting those as well. That goes to like the first one to correct any mistake that I leave in these videos. So sometimes I make mistakes on purpose and I leave them just to see if people are checking. So don't ever take my word for it, because like you, I'm a spiritual being having a human experience as well, which means that I still make mistakes as well. So this is all in an effort to be better, you know. So if you find a mistake of mine, if you correct it and bring it to my attention, I'll look at it. If you're right, I give extra credit for that as well. So 2 extra credit opportunities to anywhere from 3 to 4 people just now. Okay, let me keep moving forward. All right, I feel like this one is okay. So the next question came from section 1.2. The student said that she wasn't sure what's the formula for this. So this one says we're doing an acid mixture. It says if we have 120 liters of an acid solution is 75% acid, how much pure acid is in the mixture? Okay. So if it says it is 75% acid, that means we just do 75% of 120. Okay, so we're just gonna say 120 times 0.75. Okay, so I'm gonna do that here. 120 times 0.75. My first mind says that there should be 90 liters of pure acid in this solution. Okay, so I'm gonna go with 90 liters. I'm gonna leave it to you to check if it's wrong. If I made a mistake and I'm wrong and you correct it, you bring it to my attention. That's an opportunity. I'm not gonna check it. I'm not gonna look at the answer. That's just what my first mind says. Okay. So you watched the video, I just answered that one. So this one was just, again, if we have 120 liters of acid and 75% of that is acid, then we just say 75% of 120, and we got 90. So I'm going to leave that one in the video. My dog is uber distracted. You need to go to the bathroom? Do you need to go to the bathroom? Yeah, she's doing her bathroom dance. I dance like that too when I got to go to the bathroom. I start like pacing around the room, doing circles. I think she's okay. I think she just wants some attention. Hey, give me a few. Just wait. Give me some time. Okay, almost done. This next question comes. We have two more. We have this one and one more. This next question comes from section 1.3, question 54. I think we're just asked to write this in standard form, so basically simplify. Okay, let's go line by line. So now the first one, there's nothing. Let's go like this. Nope. I'm gonna choose a color at random. Okay, I think I got one. I don't want that color. I know I said one at random. I'm gonna do this color. Okay. So this first term, I'm going to leave it. But this second one, notice there's a negative in front. We have multiplication over addition. So I'm going to distribute this negative. I think that's the only thing that has distributing going on. So here I want to distribute the negative 1. Okay. So if we do that, the 3 root 7 is just going to come down. That's going to give us a negative 4 times the square root of 7. That's going to give us plus I. We're going to have minus 4I. So nothing to distribute to the next one, so we're going to say minus 2 times the square root of 7 plus 5I. Okay? So then what we want to essentially do is go ahead and combine like terms. Okay? So let's see. Now to add radicals, because the radical is the same, they're all square root of 7, exactly the same. We can combine those. Those are like terms. So then 3 minus 4 is negative 1. Minus 2 is negative 3. So then that's going to give us a negative 3 times the square root of 7 for those. Then we have So then we have 1I minus 4I is negative 3I plus 5I is what? 2I. So plus 2I. Okay. So the main thing here was that in order to add radicals, they have to be the exact same. Same index with the same radicand. So this radical, they're all square root of 7, so we can add these. So then 3 minus 4 is negative 1. Minus 2 is negative 3. So we got our negative 3. And then 1I minus 4I is negative 3I. Plus 5I is a positive 2I. Okay. So I'm going to go with this one. If you find an error, if you got a different answer, if you correct me, bring it to my attention. I'll offer extra credit for that. Okay. And I think this is the last one. Comes from section 1.3. This is question 85. So we have modeling alternating current. Complex numbers are used to describe a current I, voltage E, and impedance Z, the opposition to a current. These three quantities are related by this equation E equals IZ, which is known as Ohm's law. Thus, if any two of these quantities are known, the third can be found. In each exercise, solve the equation E equals IZ for the remaining value. So in 85, they give us I, and they give us Z, so they're asking us to solve for E. Okay, so we have again that E is going to be equal to IZ, or Z, as they seem to like to say internationally. So we're going to solve for E. I is 5 plus 7i. Z is 6 plus 4i. So then what we do here is FOIL. FOIL stands for first, outer, inner, last. And we use that when multiplying. We use it with binomials, but this is the same concept. Okay. So if we say the first times the first, 5 times 6 is 30. Outer times outer, 5 times 4 is 20i. Inner times inner, 36, 42i. And last times last is 28i squared. Now, in class, when we introduce I, we define as the square root of -1. The whole point is now we have something that when we square it will give us -1. So I squared is -1 by definition and everything. So that's really a -28. So then 30 minus 28 ends up being 2. 20 plus 42 is 62. Okay. So my claim is that, what are the units here? Are these ohms? Anyway, so then the claim is that E is going to be 2 plus 62i. So again, if this is wrong, I'll offer extra credit for the corrections. Okay, I'm not going to check it right now. Something like this, only way I really see to check this is just by being meticulous. But at home, you can look at the answers for these. So the answers for the I questions are in the back of the book. Okay, and I think that was the last one. So with that, we will end the session here, and from one beautiful mind to another, enjoy the rest of your evening. Thank you, Malachi.